All right, here's the in-class worksheet for Part C, infinite limits. Let's take a look. Number one, limit as x 3x as x goes to negative infinity of 3x squared plus 2 divided by 2x squared minus 5. Well, let's look at the highest order terms, and that is x squared. So I have 3x squared over 2x squared. As that goes to negative infinity, well, these two x squareds are going to cancel out. I'm just left with 3 halves. Let's look at the next one. As x approaches infinity, the limit of 4x squared plus 3x minus 7, all divided by 3x cubed minus 8. This equals, if we're just looking at the highest order again, the limit as x goes to infinity of 4x squared divided by 3x cubed. Well, the x squareds cancel out, and I'm left with 4 over 3x. Well, as x goes to infinity, that's going to go to 4 over infinity, which is equal to 0. Number 3. Limit as x goes to negative infinity of this. Well, I'm just going to look at the highest order terms. So I'm going to look at it as x goes to negative infinity of 9x to the fourth over 12x cubed. Well, that reduces to 9x over 12. And as x goes to infinity, well, that goes to infinity. All right. Limit as x goes to infinity of, oh, that was supposed to be negative infinity. Sorry, I just realized that. So that's an error there. That should be negative infinity. Number 4, limit as e to the x as x goes to infinity. Well, that's simply infinity because e to a large power is quickly going to go to a very large power, very large number. All right, number 5, as limit as x goes to negative infinity of e to the x. Well, that would be the same as limit as x goes to negative infinity of 1 over e to the negative x. Well, as that goes to negative infinity, this negative becomes a positive, so that's going to be e to the x, which is going to be infinity. So 1 over infinity is equal to 0. The limit of as x goes to negative infinity of e to the x squared, well, x squared is going to become a very large positive infinity. So e to the positive infinity is just infinity. And number 7, limit of this, as we're going to look at just the highest order terms, limit as x goes to negative infinity of 4x to the fifth over 7x cubed. I'm left with 4x squared over 7. And as x goes to negative infinity, this is going to become a large positive number, so positive infinity. Number 8, we're going to look at the highest order terms again. As x goes to negative infinity of 7x to the fifth over 9x to the fifth. Well, the x to the fifth cancel out. I'm just left with 7/9. Limit as x goes to infinity of e to the 2x plus 3 to the e to the x minus 7. Okay. Well, what do we have here? We have e to the 2x over 3e to the 3x. Well, the denominator is going to go to infinity faster than the numerator, so it's going to go towards 1 over infinity, which is equal to 0. Limit as t approaches negative infinity. Again, the highest order terms is the last term here, 6t squared or negative 4t squared. Well, as t goes to negative infinity, these t squareds are going to go to positive infinity and cancel each other out. And I'm left with 6 over negative 4 or negative 3 halves. Number 11, I've got two separate ones here. I've got the limit as x approaches infinity of 1 over 3x squared minus the limit of as x approaches infinity of 5x over x. Well, the x's cancel out here. 1 over 3x squared, that's going to go to 1 over infinity, which is 0. Minus, this is just going to go to the constant 5. So 0 minus 5, that should be a negative 5. We get another mistake there, sorry. Negative 5. And finally, I've got two more here. Limit as x, this should be an x goes to infinity, not y. Limit of 7 is just 7. And then the second one, I've got 2x squared over x squared. The x squareds cancel out, just left with 2. 7 plus 2 is equal to 9. And this one, limit as x goes to infinity of x squared over 2 to the x. Well, we have different exponents here, but the x in the denominator, this power is going to go um, to infinity much faster than x squared. So if you were to graph this, you would see that this would approach 0. So on any of these, you could graph them, and you could probably tell just by looking at the graph. But um, that's how we would do it mathematically. So anyway, hopefully that helps you, and we'll finish here.